Hi, my name is Sean Ernst, and today I'm here to talk to you about work that my team at the OU IPPRA and I have done into understanding broadcaster coverage of simultaneous tornado and flash flood events, or TORFF events. Some motivation for this study: on May 31st, 2013, imagine that you saw this tweet from the National Weather Service that you should not leave work or school this afternoon without checking the weather. Dangerous storms are expected to peak between 4 p.m. and 8 p.m. You keep this in mind, you go to work, you get out of work and turn on the TV, and you see this massive rotating storm west of Oklahoma City that has storm chasers and helicopters all over it. You're starting to get worried. Your work is in OKC, and you really don't want to deal with this kind of nastiness coming your way. Later, at 6:55 p.m., the Weather Service tweets that a new tornado warning will be issued for downtown Oklahoma City. And you turn on the TV again and you see an evil green cloud with power flashes underneath it approaching your area. You start to get worried. You see the radar image come up, and the broadcaster starts talking about how it's going to go right through Oklahoma City. You need to go wherever you are to be safe. So you go to the best underground shelter you know of, a culvert under the highway. This is what happened to Virginia Shrum and her family, who fled to a long drainage tunnel behind their apartment on May 31st to escape the approaching tornado. 5 people drowned in this tunnel, including 4 children. Overall, 13 fatalities occurred on this evening from flooding associated with this very slow-moving supercell, and another 8 were killed in the tornado that occurred, all of whom were in vehicles around the city of El Reno to the west of Oklahoma City. These TORFF events are an incredibly deadly situation, and that's why understanding the role of broadcast coverage, which is the #1 source of public weather information in the U.S., especially for folks ages 35 and over, is so important. This information that broadcasters are putting out there defines how users are making decisions in these complex, counterintuitive events. And indeed, these events are dangerous both because of how quickly they unfold and the counteracting safety recommendations that are given for these 2 different threats. For a tornado, you're supposed to take shelter in the lowest part of your home, whereas for a flood, you're supposed to find higher ground. These 2 counteracting recommendations can lead people to freeze like a deer in the headlights and not know what to do, or even worse, to put themselves in greater danger, such as putting themselves in a culvert to avoid the tornado, only to place themselves in the threat of flash flooding. There's also little study into what broadcast coverage actually looks like during these events. Some recent studies have looked at the Weather Service's forecasting and messaging for these kind of TORFF events, but there hasn't been a lot of investigation into the broadcast coverage. So that's what we hope to fill that research gap with this study here. So some key questions that we're asking: how do broadcast meteorologists like this guy split their coverage of tornadoes and flash flooding during simultaneous tornado and flash flood, or TORFF, events? Really, we want to know how the coverage of TORFFs also varies across both event type, which we're defining as supercellular, or the sort of typical baroclinic storm forming supercells that you might see in the plains in the spring, versus hurricanes and tropical systems, so things like Hurricane Harvey or the remnants of Hurricane Ida, which produced tornadoes in New Jersey, as well as Harvey producing tornadoes in the Houston area in Texas. We also want to see if there's differences in TORFF coverage across stations in the same designated market area, as well as if there's been any changes across time, and if there's differences across different regions in how TORFFs are covered. So to do this, with some help from researchers who have actually studied the coverage of TORFFs in the past, we captured video coverage of 6 different TORFF events and fed this into our OU IPPRA broadcast coverage analysis model, which we've called CAST.Bot. The first is, of course, from the 31st of May 2013 in the El Reno, Oklahoma City area. The next one comes from an event on the 1st of July in 2015 near Kansas City. We also have coverage from Hurricane Harvey, specifically on the 26th of August, when a number of tornado warnings were issued in Houston during some of the worst flooding of the storm. as well as an event from the 22nd of May in 2019 where we took data from 2 stations in central Oklahoma, as well as a station in northwest Oklahoma, or northeast Oklahoma. Finally, we've added some data from the 1st of September 2021 event in New Jersey, which was forced by the remnants of Hurricane Ida. We collected data from 6 stations, although we only look at 2 stations in this particular presentation. This study, or this sample, captures variation within and across designated market areas, event types, and time, so that we can answer those questions that we posed on the last slide. So, data analysis was again performed using the CAST.Bot, or the coding algorithm for storm coverage transcripts, which identifies hazard mentions in the transcripts of the broadcast coverage. An example of this you can see in this excerpt here. At this point, a broadcaster mentioned floodwaters, so a flood hazard tag is added to this line. You can see other tags get added, such as going over its banks being related to flooding, flooding again showing up, tornado warnings being a tornado hazard, as well as feeder bands being a mention of a hurricane hazard. These different lines are then labeled with those tags, and we can track the percentages of the total coverage that have these tags on them. So we can look at it sentence by sentence and see how many sentences are related to different threats or hazards. What this looks like is something like this. In the coverage from the 1st of July 2015 Lee's Summit event, we see that 17.4% of the sentences in the transcript had a mention of tornado hazard at some point. In the El Reno, Oklahoma City event on the 31st of May in 2013, it was 13.9% of sentences had a tornado mention. When we start to look at the other hazards, such as flood, wind, rain, and hail, we see a lot less coverage. In particular, the flooding coverage is much lower, an order of magnitude lower than the tornado coverage in these segments. So TORFF coverage has definitely been tornado-focused in these events. Looking at the 22nd of May 2019 events across the 2 central Oklahoma stations and the northeast Oklahoma station, we see that 13.3, 23.9, and 13% of the coverage in those 3 events, or for those 3 stations for this one event, was tornado mentions. Flood mentions are 0.37%, 2.57%, and 1.97% of the coverage for these 3 stations. Clearly a very, very large preference or focus on tornado coverage in these events versus flood coverage. However, when we look at more tropical system forced events, such as 2 stations covering the tornadoes and flooding in the remnants of Hurricane Ida, as well as the station covering the flooding and tornadoes in Hurricane Harvey in Houston, we see that the flooding coverage is actually a greater percentage of the overall coverage, with 6.89, 4.26, and 7.48% of coverage for these 3 stations for these events being dedicated to flooding coverage. Tornado coverage was actually less than the flooding coverage in all 3 stations for the 2 events, being 4.44%, 2.96%, and 3.17% respectively. This seems to suggest that these tropical events are seeing more balanced or flood-favored coverage versus those supercell-driven events, which really focus in on the tornadoes. Looking at the number of mentions over time, so a cumulative sum across the sentences in the transcripts, we see that for those supercell-driven events, the tornado mentions really do stand out all by themselves. It's hard even to see the forest green line that shows the flood mentions because it's clustered with the other 3 hazards, hail, rain, and wind, down at the bottom of each of these graphs. So overwhelmingly in these supercell-driven events, tornadoes are the focus. When we look at those tropical system-driven events, though, again, now we can really kind of tell the difference between the 4 or the 5 hazard lines here. Flood and rain tend to dominate, with tornadoes coming in a close second or third, especially in the Hurricane Ida coverage, where all 3 of those hazards are mentioned very consistently with each other. When we compare all of the transcripts by taking the number of tornado mentions and subtracting the number of flood mentions, we see that those tropical-driven events stay below 0, which means there were more flood mentions than tornado mentions, whereas those supercell-driven events really go up into the 200, 400, 600 more mentions, tornado mentions than flood mentions area. So we're really seeing that disparity quite clearly in this plot. So some conclusions based on this data. Tornadoes are pretty favored for coverage during supercell-driven events, but the coverage is more balanced, maybe even slightly favoring flooding during tropical events. There's an order of magnitude more tornado mentions than flood mentions in the supercell events, but we also don't really see a clear change in coverage rates over time, with those earlier two events that were supercell-driven seeing very similar coverage rates to the later May 2019 event. We also see similar coverage rates between the Harvey coverage and the Ida coverage, so there doesn't appear to be too much regional difference there either. There's wide variation across stations in one supercell event. Remember those central Oklahoma stations varying from 13% of the coverage being tornado coverage to 23% of the coverage being tornado coverage. Tropical coverage has a much more even spread, again, of those tornado and flood mentions in sentences, however. Overall, this leads us to suggest that more attention to flooding may be needed in coverage of particularly supercell-driven TORFF events. Thank you so much for listening to my talk, and if you have any questions, I'd love to hear them.